All right, so we're gonna play around with the stream flow problem in homework 3.7. So the variables here, Q stands for the flow rate. So in this case, we'll have to figure out what that is. The area is just, imagine we take a slice of water, like a piece of paper type slice of water. What's the area of the water? And then V is how the velocity. In this case, we're measuring velocity in meters per second. Since we're using meters for velocity, for area, we're going to do square meters. So I'm just going to write this stuff down and then we'll play around with it. So in the sentence below this one, we were told that the speed, the velocity of the water is measured in meters per second. Which is often abbreviated as an M for meters divided by S for seconds. The area is going to be measured using meters again, but an area has to be like squares, so square meters. Which we often write as M squared or meters squared. And we've got our formula here that says the flow rate, Q, just not sigma, Q, there we go, is equal to the area that the water is going through times the speed of the water there. And we were told that the area has to be meters squared whenever we measure it. And the speed, the velocity, you can also call that speed, has to be meters per second. And if we put those two units together to multiply fractions, I would write that as meters squared over 1 times meters over seconds. Meters squared really means meters times meters, and now I'm multiplying by another meter. So my numerator is now meters cubed per second. And so meters cubed, we often read as cubic meters per second. And so thinking about cubic meters, that's like an actual cube. So here's my best picture of a cube today. And that cube measures 1 meter by 1 meter by 1 meter, which is a pretty big chunk of water. And we're looking at how fast that chunk of water is moving, and that's what's called the flow rate. So a chunk 1 meter by 1 meter by 1 meter per second is the flow rate. So this right here, cubic meters per second, is how we measure the flow rate. And so as we're answering questions, we just got to make sure the units match up. So if somebody throws feet per second or miles per hour or square feet at us, then we got to recalculate that to use it in the formula. So let's see what kind of questions we have to answer with that. First one said units must be consistent. And again, I just went over that. The V are meters per second and the area is square meters. And when we put those together for Q, we get cubic meters per second or meters cubed per second. And that should be one of our options there. Square meters, nope. Cubic meters, seconds, nope. Cubic meters per second. So this is the only one that seems to be worded correctly. Cubic meters per second is what we have there. And then they asked us to solve this formula up here for V. So let's see. If we want to get the V by itself, we would have to get rid of the multiplication. So starting with Q equals A times V, I want the V to stay. The only way to get rid of a multiplication is divide the A away. So I got to divide that A to the other side. And the point there is a number divided by itself is 1. Hey, Brennan, we're taking a look at, which homework problem is this? This is number 4 in the homework.
Are we done with class?
If you want to be. Otherwise, we're just going to look at some homework problems.
Okay, yeah. Thank you. Have a good day.
Okay, take care, Brennan. All right, so the A's cancel on the right side, so I should just have V equals just Q over A. So we rewrote the formula. And for one of the later questions, will you need to use this other version of the formula? All right, so here we're given some information. So let's see, the stream has a cross-sectional area of 8 square meters, and the velocity of the water past this point is 2.4 meters per second. What is the flow rate? So that one I think is pretty straightforward. Let's double check by picking it apart. All right, so let's see. The stream has a cross-sectional area of 8 square meters. All right, so we're given that A, the area, is 8 square meters. It's not a bad idea to summarize those meters, which sometimes we write just as 8 meters squared. And then the velocity, that's in meters per second, which is what we were told in the beginning, so that seems good. 2.4 meters per second. And we want to know what is the flow rate, so that's our Q, that's our A, that's our V there. And Q, according to the formula, is just V times A, or A times V. So then I should just be able to take the 8, multiply by 2.4. My units are what I was told I should start with. And so just whip that out on a calculator, and your numbers might be a little bit different than mine, so be careful with that. So I'm going to get 19.2. And the computer claims the answer should be meters cubed per second. And let's just double check. With the 8, that was meters squared. And this was meters per second. And yeah, meters squared times meters is meters cubed. And I still have the per second there. So that does look right when I look at the way the numbers are measured. All right, let's try the next part. The next part says, what is the speed of the water if the flow rate is 16 meters cubed per second and the cross-sectional area is 12 square feet? Sounds like a problem. Sounds weird here. What is the speed? So that would be V, so I don't know that. The flow rate, that's my Q. That's 16 meters cubed per second, so that looks okay. And then the area, A, they're saying is 12, but they said that's square feet or feet squared. And right away we should see, oh man, that's not meters, that's a problem. So we need to convert that in order to use the formula, because we need meters squared. And there's a couple ways to go about this. One super easy way is to just search feet squared to meters squared. And Google will kindly say, hey, sure, we can do that. So if I started with 12 feet squared, Google says that should be 1.11484. Otherwise, we could use conversion factors, but this looks pretty nice. So 12 square feet is 1.11484 square meters. One 1.11484. All right, so now I have the correct units. We solved that formula before that said V is equal to Q over A, right? That was that second part that we did. Our Q is 16, and our new correct A is 1.11484. And just to double check, this number here is in the top, meters cubed per second, and I'm dividing that by meters squared. And if I clean that up, dividing by a fraction is multiplying and flipping. So this would be meters cubed per second times 1 over meters squared. And in a previous course, this was covered. If you have something like meters cubed over meters squared, that cleans up to be keep the m for meters, and then power is 3 minus 2. 3 minus 2 is 1. M to the first power is just m. So this is just meters per second. And that's what velocity should be, meters per second. So all we have to do is whip out on our calculator what is 16 divided by 1.1184. Hey, Natalie and Brenda, we're just playing around with the homework. I'm going to do another problem in just a moment. So calculator. So I had 16 divided by 1.1144, and I get about 14.4. How many decimal places do they want? 1. Perfect. Yay.